Welcome to all of you. In this lecture, I will cover the Gauss Seidel Iterative Method. So, before going to any example, let us first understand the basic theory of Gauss Seidel Iterative Method. So, why iterative method is needed? So, in certain cases, when a system of equations is large. So that is Gauss Seidel iterative method is also for solving a set of linear equations. Okay. So in my previous lectures, you have seen Gauss elimination method, Gauss Jordan method, but these elimination methods are not always applicable. So when these methods are not very efficient, then the iterative method comes. So, why the elimination methods are not applicable always? These methods, like the Gauss elimination methods, are prone to large round of errors when the system of linear equations is large. Okay, so large set of equations is there and you are applying Gauss elimination method or Gauss Jordan method, then it may happen that there are large round of errors. So that is the disadvantage. So iterative method actually is more advantageous in these cases when the system of linear equations is large. And in case of Gauss Seidel iterative method or iterative method, initial guesses are given. Okay. So in general, let us take some system of linear equations. So suppose there is a general set of n equations. So suppose there is a system of n equations, linear equations. Okay, you are dealing with linear equations. When there are n linear equations, so there are obviously n unknowns, that is n variables. So the equations are like this: a11x1 plus a12x2 plus a13x3 plus up to a1nxn is equal to, suppose, c1. So from here, if we want to find out the value of x1, what will happen? x1 is equal to, just we make this c1 minus, okay, let me just write down in this way. So just we do in this a11x1 is equal to c1 minus a12x2 minus a13x3 minus minus a1nxn. Okay. So x1 is equal to c1 minus a12x2 minus a13x3 minus minus a1nxn divided by a11. So in this way, from equation 1, we can find the value of x1. Okay. Similarly, suppose we have found the value of x1. Similarly, we have n equations as we have already told. So another equation, next equation is a21x1 plus a22x2 plus a23x3 plus plus a2nxn is equal to c2. So from here we can find out the value of x2 like this. So this is a22x2 is equal to c2 minus, just I am taking these elements on the right hand side. So c2 minus a21x1 minus a23x3 minus a2nxn like this, dot dot dot. Here dot 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 is there. So x2 is equal to c2 minus a21x1 minus a23x3 minus minus dot 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 minus a2nxn divided by A22. Okay. Similarly, we will find the value of a x3, x4, x5 up to xn. So the equations are like this. So these are the equations. So equations are like this. So in general, the ith equation is like this. Ith equation, I 1 less than equal to I less than equal to n. The ith equation is like this. xi1 x1, sorry, ai1 x1 plus ai2 x2 plus dot 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 ain xn is equal to ci. So in that case, xi is equal to ci minus ai1 x1 plus minus, this will be minus ai2 x2 minus dot 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 minus ai minus 1 xi minus 1 I minus 1 comma I minus 1. This will be continued like this here. ai plus 1 comma ai comma I plus 1. It will be I comma I minus 1 ai plus 1. Sorry. This will be a I plus 1 comma I comma into xi plus 1 plus dot dot dot. So it will be like this divided by ai. So that is xi. In general, this is the structure for all the equations. Okay. And finally, what you have to find out? Just you have to find out the error of each and every iteration like this. Error of the ith value of xi. So it is like this. This is epsilon a for ith term. This is xi new. So at every iteration we will find the new value of xi minus xi old divided by xi new into, this is into 100%. Okay. So that is our way to solve linear equations using Gauss Seidel Iterative Method. Now let me move to the example. So in the Gauss Seidel Iterative Method, the question will look like this. So this is a system of linear equations. 12x1 plus 3x2, 12x1 plus 3x2 minus 5x3 is equal to 1. x1 plus 5x2 plus 3x3 is equal to 28. 3x1 plus 7x2 plus 13x3 is equal to 76. And here the initial guess will be given as you have seen, you can see here, that is x1, x2, x3, that is 1, 0, 1. So x1 is given as 1, x2 is given as 0, x3 is given as 1. That is the initial guess. The final solution you have to find out, but this will be given to you. So how to proceed? Okay, one thing you have to consider while proceeding with Gauss Seidel Iterative Method. What is that? The thing is that you have to check whether, so first you have to make a matrix form of this equation. We don't need to find out the augmented matrix. We need to find out the coefficient matrix. So what is the coefficient matrix? So from the first equation, we find the coefficient of x1 as 12, the coefficient of x2 as 3, the coefficient of x3 as 5. In the second equation, the coefficient of x1 is 1, the coefficient of x2 is 5, the coefficient of x3 is 3. In the third equation, the coefficient of x1 is 3, the coefficient of x2 is 7, the coefficient of x3 is 13. Now, what you have to do, before proceeding, we have to check whether this matrix is diagonally, you have to check whether this matrix is diagonally dominant or not. Okay, diagonally dominant or not. If this matrix is not diagonally dominant, then using the Gauss Seidel iterative method, you may or may not find out the solution. But if it is diagonally dominant, it is obvious that you will find the solution. So before proceeding, you have to check whether this coefficient matrix is diagonally dominant or not. So how to check whether the matrix is diagonally dominant or not? So for that, what you have to do? You have to just let me just write down freshly. So just I have written the coefficient matrix freshly. So as you can see, this is the coefficient matrix A. The matrix is like this, 12 that we have obtained from the equations in the last slide. Now you have to check whether this matrix is diagonally dominant or not. So what are the diagonal elements here? 12, 5 and 13. So you have to check whether the absolute value of 12, or just in general you can write whether the absolute value of A11 is greater than equal to the sum of the other elements in that row. That is, here this value is absolute value of A11 is 12. So you have to check whether 12 is greater than equal to the absolute value, sum of the absolute values of other two elements in that rows, or other elements in that row. So 3 plus absolute value of -5, that means 3 plus 5, so 8. So 12 is greater than equal to 8. Yes, it is true. Now, next diagonal element is 5. So A22, that is 5, that is the absolute value. Whether this value is greater than equal to sum of the absolute values of other two elements in that particular row. Other two elements means 1 plus 3, so it is 4. Yes, 5 is greater than equal to 4, so it is also true. What are the last diagonal element? That is A33, and it is equal to 13 absolute value. It is greater than equal to the other absolute values of the other two elements in that row. So that should be it is, you just write 3 plus 7, so it is 10. So 13 is greater than 10. So we see that all the diagonal elements satisfy this condition. So we conclude that this matrix is diagonally dominant, diagonally dominant matrix. So Gauss Seidel iterative method can be applied on this matrix to find out the solutions of the system of linear equations, and the solution will definitely converge. If this matrix is not diagonally dominant, then you cannot surely tell whether you will find the solutions for this matrix. Okay, so that is the thing. Now, let us move on to second step. So, first you check whether diagonally dominant matrix or not. If it is so, then we move to the next step. Okay. Okay. So, I have written down the equations again. So, as in the theory part, you have seen what to do. Just from this, we will first find the value of x1. So x1 will be like this. So this is 1 minus 3x2 plus 5x3 divided by 12. So x1 is 1 minus, so all these except this part we have shifted these other parts to the right hand side of the equation. So 1 minus 3x2 plus 5x3 divided by 2. What is x2? In the similar way, we find x2 as 28 minus x1 minus 3x3 divided by 5. And we have to find out the value of x3, that is 76 minus 3x1 minus 7x2 divided by 13. Okay. So that is how we find out the values of x1, x2 and x3, but in the terms of other variables. Now, at iteration 1, iteration number 1, we use the initial guess. So what was our initial guess? In the initial guess, it was given x1 as 1, x2 as 0, x3 as 1. Okay. So if we put the values of x1, x2 and x3 in these equations, that is, now x1 becomes 1 minus 3 into x2, x2 means 0, plus 5 into x3 means 1 divided by 12. So it becomes 1 minus 0 plus 5 divided by 12. So 6 by 12, that means 0.5. Okay, so x1 is 0.5. I am writing here. Now at iteration 1, we find x1 as 0.5. Okay. Now, sorry, okay. Just remember x1 is 0.5. Now, so we have found x1 as 0.5. So what is our x2? x2 is 28 minus x1. Now we use the updated value of x1, that is 0.5 minus 3 into x3 minus 3 into x3. x3 means 1 divided by 5. So 28 minus 0.5 minus 3 divided by 5. If you calculate this becomes 4.9. So now you find out x2 as 4.9. Okay. Now similarly, if you find out x3, so x3 is 76, and you now use x1 as 3 into 0.5 minus 7 into x2 means 4.9 divided by 13. Okay. So that means 3.09. So these are the values you obtain after first iteration. x3 is equal to 3.09. So these values you obtain after this iteration number 1. Now let me clear this screen and go on to iteration number 2. But before that, we have to find out the errors. Okay, how I am telling you. So now let me delete this page contents and we just write down as. So what was our previous value? What was the initial guess? x1 was 1, x2 was 0, x3 was 1. That was our initial guess. At iteration 1, we find x1 as 0.5, x2 as 4.9, x3 as 3.09. Now we find out the error. So error is for x1, the error is new value of x1 is 0.5 minus old value of x1 is 1. Old value is 1 divided by the old value into 100%. Okay. So this is basically 0.5 by 1. That means divided by the new value, so it is 100%. The error is 100%. Similarly, what is the error for x2? It is the new value 4.9 divided by the old value 4.90 divided by the old value, that is 4.9 minus 0 by 4.9 into 100%. So it becomes also 100%. What is for x3? So it is for 3. What is the new value? 3.09. What is the old value? That is 1. Old value is 1. As you can see here, old value is 1. So 1. And what is the new value? 3.09 into 100%. Okay. So if you calculate this, it becomes 67.66%. So you see, in both cases, in x1 cases of x1 and x2, the error is 100%, and in case the error is 67.66%. See, this is at iteration number 1. We have to continue these iterations, that is iteration 2, iteration 3, iteration 4, so on, till the error rate is very negligible or very close to 0. Okay. Unless there is any instruction that you have to stop at iteration number 2, 3 or 4 like this. So you have to carry on this process unless you find out the error as almost 0% or the values or the error, yes, the error values are almost 0%. Okay. So let me move to now iteration number 2. So what is our iteration number 2? Let me clean this screen. And we write down again. So what is our at iteration number 2? At iteration number 2, what is our values of x1? x1 value is 0.5. The value of x2 is 4.9. The value of x3 is 3.09. Okay. And we have found the error as we have seen previously. Now, in the same equation as you have found. So what was the equation? x1 was like this. 1 minus 3x2 plus 5x3 divided by 12. x2 was 28 minus x1 minus 3x3 divided by 5. x3 is 76 minus 3x1 minus 7x2 divided by 30. So now if you put down these values as you have obtained in iteration 1, now this is iteration number 2 and you are putting down these values. So x1 becomes 1 minus 3 into x2. x2 means 4.9 plus 5 into x3. x3 means 3.09 divided by 12. Okay. So that becomes 0.14679. If you calculate this, it becomes like this. What is the value of x2? It becomes 28 minus x1. x1 means now you have to put this updated value of x1. 0.14679 minus 3 into x3. So what is the value of x3? The value of x3 is 3.09. x3 is 3.09. So 3.09 divided by 5. Now if you calculate, this value becomes 3.71, sorry, 3.7153. Okay. Now these updated values you put on this to find out the value of x3. So it is 76 minus 3 into x1. x1 means 0.14679 minus 7 into x2. x2 means this value 3.7153 divided by 30. So if you calculate this, this becomes 3.8118. Okay. So let me just write down these values freshly. Now these are the updated values of x1, x2 and x3 after iteration number 2. So what is the value of x1? The value of x1 is, as you have obtained, 0.14679. The value of x2 is 3.7153. The value of x3 is 3.8118. Okay. Now you find out the error. So the error for x1 after iteration number 2 is the new value of x1, that is 0.14679 minus 0.5 divided by the new value 0.14679 into 100%. Okay. So that becomes 240.61%. So please do not get confused if the error increases. This actually becomes at the initial phases. Okay, but later on, while you will continue your operations, the values, error rates will reduced. So A2, the error for finding out the value of x2, it is the new value of x2, that means 3.7153. 3.7153 minus old value of x2, that means 4.9 divided by the new value, that means 3.7153 into 100%. Into 100%. So it is if you calculate this, this will become 31 points. So in this case, we find the error for A2. We find, sorry, there is some disturbance in my pen tab. So I'm writing here with my hand. I'm sorry for this inconvenience. So in the similar way, we find the error for A2 as 31.889. Okay, you see the error is reduced. 31.889. Just the similar calculations. New value minus the old value divided by the new value. Okay. And the third one, that is for error of the third one is if you do the same thing, you find the error is also reduced. That is 18.874%. Okay, just follow my words. Do not I'm not writing it properly. I cannot actually. So 18.874%. Okay, so you see the error, though the error is increased at for x1 also, the error for x2 and x3 is 31.889%, x3 is 18.874%. Okay, so these are the errors, but you have to do iteration number 3, iteration number 4, iteration number 5 until the error is less than a negligible value or a predefined threshold, or it is close to 0. So in this case, for this particular case, if you go up to 6th iteration, then after 6th iteration, at iteration number 6, you will find the value of x1. You will find the value of x1 as, this will be as 0.99. This will be as, I don't know whether text will work or not. It will be like 0. I'm writing it in this way, 0.99919. Okay, sorry, 19. The error will be, the value of x1 will be 0.99919. Okay, the value for x2, also will be like this. The value for x2 will be like this, 3.0001. Okay, you see the value will be like this, 3.0001. Sorry, it will be the value for x2. And what will be the value for x3? The value for x3 will be like this. x3 will be equal to 4.0001. Okay, so these are the three values we find after 6th iteration. This is basically the sixth iteration. Okay, and if you find the error rates, so at the 6th iteration, you will find the error for x1, that will be analyzed in the same way. It will be found as 0.770.74307%. The error for x2, will be calculated as 0.10856%, and the error for x3, these are the errors. Okay, the errors for x3 will be 0.00101%. Okay, so these are the values, these are the error values, and you see that these error rates are almost 0%. Okay, so you now stop and you just tell that you have obtained the solutions for our linear set of linear equations. So the value of x1 is, if you approximate this 0.99919, that is written here, you find it as 1. The value of x2 is, this is 3.0001, so this is 3, and the value of x3 is 4. Okay, so that is the final answer. So in this way you have to proceed until it is also so when if it is mentioned that the error rate is should be less than 5%. So when the error, suppose after fifth or fourth iteration, the error rate is less than 4%. Okay, so then you stop. But if it is not, if nothing is said, so you have to proceed and you have to do the same things repeatedly with the new values or updated values and compare with the previous values, and you have to find out the errors. If the error is similar to or very close to 0%, then you stop. Okay, so this is the solution using Gauss Seidel Iterative Method. Thank you.